Hey everyone. We're going to take a look at section 7.4 today, which is solving polynomial equations in factored form. So our essential question, what we want to be able to answer by the end of this lesson is, how can you solve a polynomial equation? First off, we need to figure out what factored form is. So factored form, the definition is a polynomial written as a product of factors. So here's an example of what that might be. Let's say you have the polynomial x squared plus 5x minus 24. Okay, the factored form of that would be, you'd have x here, and then you'd have like a -3 and a +8. So this is actually factored form. So we're going to be dealing with that a lot the next couple of days, working backwards. Once we'll be given a polynomial and we're going to have to get it into factored form. The zero product property, you might hear me call it the ZPP a little bit. That is the product of two real numbers, or I should say, if the product of two real numbers is 0, then at least one of the numbers is 0. And we'll be talking a lot about the ZPP on the next few slides. It's a nice way to help you solve polynomial equations. So yeah. And then the roots are just the solutions of a polynomial equation. And a repeated root is where you have two or more roots, so two or more solutions of an equation that are the exact same number. And we'll have an example of that on some of the next slides. So make sure you get these written down. Pause the video if you need to. I'm going to move on to the next slide and do the first couple of examples. Oh, actually, let's talk about the core concept first. So the zero product property is one of our core concepts, and you already have this down as the definition, but make sure you get the algebra written down. So this is basically if A and B are real numbers and A times B is 0, then either A or B must equal 0. Again, just a core concept so that we understand it. Let's go ahead, let's take a look at your first couple of examples. All right, so basically what's going to happen here, you guys, is we're going to take each of these two pieces and we're going to set them equal to 0. Notice right now how you have both of these, and this is going to stay pretty consistent. Both of these are equal to 0. Okay, and that's something that you want when you're trying to find these polynomial equations. So first thing we're going to do is we're going to take each of these separate pieces and we're just going to set it equal to 0. This is going to help us come up with our solutions. Now you've got two quick one-step equations. And boom, there's solution 1. And there's solution 2. So really, you guys, you're just taking each of the separate pieces, setting them equal to 0, and then you're solving. The nice thing about these is that now when you plug either one of these numbers in, so either 0 or 4, you should still come up with 0. So if I take 2 times 0 and then 0 minus 4, and I set that equal to 0, well, inside here you're going to get -4, but you've got 2 times 0 times -4. So that'll turn into 0. Same kind of thing if you take 4 and you plug it in for both of these x's. 2 times 4 is going to give you 4, or 2 times 4 is going to give you 8. And then 4 minus 4 on the inside of the parentheses, if you subtract them, that's going to turn into 0. So then again, you're just going to end up having 0. Okay. For problem B, same exact type of problem. You're setting it equal to 0. X minus 9 equals 0. You've got one-step equations now. Go ahead, add 3, add 9, solve. So one of your solutions is x equals 3, and one of your solutions is x equals 9. Again, if you take and you plug 3 in for both of these, you're still going to come up with, you're going to have 3 minus 3. That's going to turn into 0. 0 times whatever this turns into should be negative 6. 0 times negative 6 is still going to give you 0. And then kind of along the same lines, if you take 9 and plug it in for each of these, right, over here, that's going to turn into 0. 0 times 6, that's still going to give you 0. All right. What I encourage you to do now is go ahead, try the next 3 examples. So 1, 2, and 3 on the next page. Solve them, pause the video, and then I'll go ahead and I will talk about the solutions in just a second. And I promise I will come back. Okay, so here, again, you're taking each of the separate pieces, you're setting them equal to 0. So in the first one, actually, the first one that you set up is already the solution. So x equals 0, and then your other solution is just x equals 1. Again, if you take either of those numbers and you plug them in, you will still come up with 0. For number 2, same kind of thing. 3t equals 0, t plus 2 equals 0. Solve, and you end up with 0 and negative 2. And then for number 3, you come up with z equals 4 and z equals 6. For the next 3 examples, your solutions turn out to be slightly different than those of the first 3 examples. And I'll show you how in just a second. So let's look at part A, where you've got 2x plus 7 equals 0, and then you've got 2x minus 7 equals 0. Okay, now notice the big difference between these two is that the only thing that's different is the sign. So really, you've got 2 two-step equations here. They're going to go quick because you guys are masterminds and super, super fast at this stuff. So 2x equals, that's not 2, it should be negative 7. If I add 7 here, now you've got 2x equals positive 7. For both of these, go ahead and divide by 2. So then you've got x equals negative 7 halves and x equals positive 7 halves. So you have 2 separate roots, one positive, one negative. And make sure that you get both of them down, because like when you're doing your homework and stuff, they're going to want you to show both roots. Okay, now letter B is an interesting problem because there's 2 ways that you can solve it. First way that you can solve it, and the way that I kind of like better, just because I don't know why I like this one better, just because I do. Take each of these, since you've got this squared up here, take it and separate it into 2. And then once you've done that, set it equal to 0. Then you're going to go ahead, you're going to add 1 to both sides for both of them, because again, you've got the exact same root, or sorry, not root, you've got the same exact binomial. You're just solving it twice. So you come up with the repeated root. Now, when you look at your homework, you're only going to need to list it once. You are not going to need to list this twice. Okay, but a second method that you guys may like is, what I can do here is I can start by just taking the square root of each of these. So when you take the square root of 0, that just turns into 0. This square root and this squared cancel each other out. And then you'd be able to just add 1 to both sides, so you get x equals 1. So realistically, there's 2 ways to solve it. I don't care which one you do, whichever one you're most comfortable with. Totally and completely up to you. Okay, let's take a look at letter C quick. So you're taking x plus 1, again, setting it equal to 0, that zero product property. X minus 3, setting it equal to 0. X minus 2 equals 0. You have 3 one-step equations here. Subtract 1. First solution is x equals negative 1. Second solution, we're going to go ahead, we're going to add 3 to both sides. So you've got x equals 3. Third solution, add 2 to both sides. So you just have x equals 2. For this one, make sure that you go ahead, you solve all 3. And again, now I just encourage you to go to the next slide or the next few examples, try them out, come up with your solutions. I'm going to pause the video and I'm going to do the same. All right, here are my 3 solutions. I didn't give myself much room on that number 4, so just make sure that you guys can find them up here and right here. So S equals negative 5/3 and S equals negative 8/5. And then you've got B equals negative 7 for problem number 5. Again, don't care which way you decide to do it, whether it's that top way or whether it's that bottom way. Figure out what works best for you. And then for number 6, you've got D equals 2, D equals negative 6, and D equals negative 8. Okay, just a couple more examples that we're going to do, and then I will be done with this video. So for this problem, and I realized I made a mistake when I was going through and getting this ready. So you guys on your packet just have x to the 4th. You don't have 4x to the 4th. But what you're going to do, and I'm pretty sure there were problems like this on your homework today, and I had a couple of people come up and ask me about it. You're going to factor out the greatest common factor. Okay, now what that means for those of you who might have struggled with this or maybe aren't done with your homework from today, what you want to do is you want to find the factor that occurs the least often, I guess you could say, or the number or variable that you can take out the most. And for us, since you don't have any like leading coefficient in front of that x to the 4th, you can really only take out a variable. And you would only be able to take out the smallest amount of that variable. So you would only be able to take out x cubed. Once you have taken out x cubed, then you're left with x plus 24. And that's all there is to it. It's pretty straightforward. Okay, so I would love for you guys to pause the video and try this one on your own. I know I only gave you one example, but even when I was explaining it to those couple of people this morning, it seemed like it went fairly quickly. So I encourage you to pause the video, try it, and then I will come back on in just a second. All right, so there it is. If you look, you can take out an 8, a factor of 8 from both 8 and 24, and you can take out a factor of y. So that's going to leave you with y minus 3 inside the parentheses. Okay, we're almost there. So basically what's going to happen here for these examples, you guys, is we are going to put both the zero product property and the taking out of the greatest common factor into the same problem. So when we look at letter A, you've got 2x squared plus 8x equals 0. We don't really have any other methods to solve this quite yet, other than right now, let's start by taking out a greatest common factor. So I see a factor of 2, and I also see a factor of x that I can take out, which leaves me with x plus 4 inside of here. Okay, now I have this set up just like the first couple of examples that we did. Take 2x, set it equal to 0. Take x plus 4, set it equal to 0, and just solve. So you've got x equals 0 on the left-hand side. And then you've got x equals negative 4 on the right-hand side. Okay, let's try letter B together. And then again, I'll have you guys try the next three on the next slide, or the next 3, 8, 9, and 10 on your own. So I've got 6n squared, equals 15n. Okay, this is a good problem. Notice, and what I've talked about before, is that we want all of these polynomial equations to equal 0. Well, right now, this is not equaling 0. So what we need is to, first off, get everything together on one side. So we're going to take 6n squared minus 15n equals 0. Okay, now we're in a good spot. What's our common factor? What can we take out of this 6n squared minus 15n? Let's see, I can't take out a 6, but I should be able to take out a 3, and then I can also take out an n. So if I take out a 3, then I'm left with 2n, and if I take out a 3, I've got 5 equals 0. Again, take each of these pieces, set them equal to 0, and solve. Nice quick one-step equation over here. Here, it's just a quick two-step equation, add 5. All right, so we're not going to get a nice whole number as our answer, but that's okay. We're going to come up with n equals 5 halves. Okay. Go ahead, try 8, 9, and 10. See what you can come up with. Pause the video. I'm going to pause my video. And then we will go on. We'll do the word problem together. And then you will be done. Okay, so here they are. On number 8, again, you're just taking that factor of a out. That's all you can do. On number 9, I don't know why they're using the variable s for some reason. It's not a very good variable to use in algebra. Anyway, you're taking out a 3s. And then in number 10, that's exactly like example B that we did on the other slide, or on the just above, where you have to subtract 2x over to the other side and then solve. So you should, for number 8, come up with 0 and negative 5. For number 9, come up with 0 and 3. And then for number 10, should be 0 and 1/2. Okay, last example. So here's what we've got. Let's see, I don't think this is the example you guys have on your papers. Here it is. Okay. So you can model the arch of a fireplace using the equation y equals negative 1/9 times x plus 18 times x minus 18, where x and y are measured in inches. Okay, so what we want to do, so you're going to find the width of the arch at floor level. So if we kind of think of this, okay, here's an x and y axis, and here's kind of just that basic shape of a fireplace. We basically want to figure out from this point right here to this point. So finding the width, finding the distance between these 2 points. So let's just take our equation, y equals negative 1/9 times x plus 18, and then I've got x minus 18. All right. Now, this is not a time where I have 0 set in for y quite yet, but I'm able to, right now, notice how this picture, it's crossing the y-axis at 0. So I actually do have the ability to just go ahead and say, okay, I'm going to have y equals 0 here. So I'm going to have 0 equals negative 1/9. I've got x plus 18, x minus 18. But right now I don't fully have it in factored form. Like, those two binomials are not all by themselves. So what I'm going to do is I'm going to start by multiplying both sides by -9, just so that I can get rid of this fraction right here. Because then I'm going to have x plus 18 and then x minus 18 equal to 0. Then I'm going to be able to set each of these equal to 0. And I don't know about you guys, but I'm just going to adjust this so that 0's on the right-hand side, just because that's how I'm trained. I'm always trained to have 0 on the right-hand side. And then we just go ahead and we solve quick. So subtract 18 from both sides. So you've got x equals -18. Add 18, add 18. X equals 18. Okay, so here's what these are saying. This point right here is at -18, and this point right here is at +18. So we got to figure out what's the distance between these two. And if you take and you just kind of think, okay, -18 is 18 away from 0 on the number line, and then 18 is 18 away from 0 on the number line, that gives you a total of 36 inches of distance for the width. All right, ladies and gentlemen, I am officially done with this. You do not have to do your assignment right now. Finish up your 7-3 assignment if you're not done with it, but we'll do 7-4 together in class, and then I believe Thursday you guys will end up having a quiz, so make sure that you are prepared for that. We will see you guys tomorrow.